Hello friends, today we will discuss the energy of an electron in Bohr's orbit. We know that the total energy E is equals to kinetic energy, sum of kinetic energy and potential energy. Kinetic energy is expressed as half mv square, where m is the mass of the electron, mv is the velocity of the electron, and potential energy, that is equals to minus z square by r. How it is coming? Potential energy. Potential energy expression is z square by r square, integration from infinite distance to r distance. That is the from infinite distance to r distance, the amount of energy released, that is called the potential energy. And if we integrate it, the expression is coming minus z square by r. Thus potential energy is minus z square by r. Another, from the calculation of the radius of Bohr orbit, we know the expression of r, that is n square h square by 4 pi square m z square. Another, when an electron is moving around the nucleus of charge Ze and the distance of the orbit is r, radius of the orbit is r, and the mass of the electron is m and velocity is v, then the centrifugal force mv square by r, that is equals to the electrostatic force of attraction z square by r square. So mv square by r or mv square equals to z square by r. So this is, suppose this is expression 1, this is expression 2, this is expression 3. Now if we combine this expression 1, 2 and 3, we will get the energy of the electron in Bohr's orbit. In this expression mv square, so if we put mv square equals to z square by r, we will get z square by 2r. In place of mv square, I am writing z square by r minus z square by r. So the resultant is minus z square by 2r. The resultant will be minus z square by 2r. Now if we put r in this equation, we will get minus z square by 2 into r equal to n square h square by 4 pi square m z square. So the expression becomes minus, here this will be 2, so 2 pi square m z and z will give z square e to the power 4 by n square h square. So E is equal to minus 2 pi square m z square e to the power 4 by n square. This is the expression of energy for an electron in Bohr's orbit. Now if we calculate the difference in energy between two states, suppose this is n1 and n2, the difference in energy will be delta E, that is equal to E2 minus E1. So it will be equal to E2, so minus 2 pi square m z square e to the power 4 by n2 square h square, minus E1, that is minus 2 pi square m z square e to the power 4 by n1 square h square. So it will be equal to 2 pi square m z square e to the power 4 by h square into 1 by n1 square minus 1 by n2 square. So this is the difference in energy between the two states. If you like my video, please like and subscribe my channel, and if you want to know more, then you can comment. Thank you.